Okay, so we are good to go. All right, so today we're looking at introduction to LoRa Wan, and then we are going to narrow down our class today to something that is a particular module, okay, which is called uh, the LLCC 68. So the LLCC 68 is a LoRa Wan module. Okay. So please, if my audio is not loud enough, please just chat me up and then I will increase my audio. So all right, but if I'm audible enough, just give me a thumbs up so I'll be able to I can proceed. Then if I'm audible enough, if I'm audible enough, just give me a thumbs up. Okay. All right. So we are good to go. All right. So what we're going to look at today's class, we're going to look in depth uh, into LoRa Wan technology. Last time we talked about Wi-Fi, and then we talked about a particular module which has to do with Wi-Fi. So we talked about Wi-Fi, how Wi-Fi works, different classes of Wi-Fi, and when it comes to their transmission, the speed, their frequency, the size of data in which they transmit. Yeah, we're able to talk about that, and then we get to talk about different types of ESP. All right, so today we are going to look at LoRa Wan, and then we are going to look at a specific module that handles LoRa technology, and then we're going to look at the LLCC 68. That is a LoRa Wan technology. So we're going to look at that today. And at the end of today's class, I'm going to drop a lot of documents, uh, like I did last time on the Slack channel. So go through that document because there are some of the things that the time allocated for us will not permit me to go through everything. All right, and then the subsequent class we'll try to see. Before the class end, I'm going to introduce you to ThinkCard, okay, which is one of the tools we'll be using from next week to do some simulation, we'll do some programming. And please just take a look at the Slack channel. I'm going to send some information in order to gather what I need. So you just give me just answer some of those questions so that I'll be able to know how to proceed in the next class. Okay, so let's proceed and then let's get into business. So what we'll be learning today, what we'll be learning today into this class, yeah, we're going to talk about what LoRa is and what LoRa Wan is. Please, LoRa is different from LoRa Wan. Okay, it's not they are not the same thing. All right. So when you hear people talk about LoRa, you hear people talk about LoRa Wan, please they are not the same thing. And today's class, I'm going to make you know what are differences between the two of them. So we're going to do that today. And then we're also going to look at how do LoRa Wan works, how are they able to communicate, and the information they are transmitting, how they're able to transmit those information. So we'll look at that today. And then we'll also look at the LLCC 68 series of LoRa Wan. And then we're going to see how we can make use of them to do what we want to do. We're also going to look at its architecture so that we'll be able to understand what how the work. So after that, we'll look at the LoRa Wan architecture, like you said, and then we'll look at some basic applications of LoRa Wan. So what are these basic applications of LoRa Wan? Where can it be used, and what other things it can be used for? So I'm going to look at that today. We are going to look at that today. Then we're also going to look at the advantages. Okay, also going to look at the advantages of LoRa Wan, okay, technology, and where it's applicable. All right, so let's start. Fully. So the question is, what is LoRa? Okay, like I said, before you're able to understand the concept of LoRa Wan, okay, first you need to understand what LoRa is. Okay, so it's not they're not the same. Okay, it's different. So now, like I said, that communication is one of the most important parts of any IoT project. Okay, you want to track sensors, you want to know the location of a particular gadget, or you want to have access to some things, some information, be it humidity or whatever. So communication is one of the most important parts of any IoT project. So now the ability of these things to communicate with each other, maybe I'm talking about the thing. Okay, when I talk about the thing, I'm talking about the hardware, and then with the cloud or the server. Okay, when I talk about thing, I'm talking about the hardware. For example, the module. Okay, just a component, some modules with some some power, and some microcontrollers on board. Yeah, that's what I call the thing. Okay, the main one that is on site. Okay, that's the thing. So now, how they're able to communicate, okay, with the thing, it was give the thing, the component now or the project now, the right to attach the internet or to be connected to the internet. So, and this also gives the name, okay, the IoT, which is the Internet of Things, okay. Now, there are lots of communication protocols out there, a lot of them, like like the one we talked about last week. There are a lot of communication protocols out there, and each of these communication protocols lack one thing or the other. So the IoT world is vast, it's growing. Okay, so there are a lot of development every day going on with what is happening. So it every day as day goes by, a lot of things are being developed, and there are a lot of protocols also being developed. So now this protocol lacks one or two things than the other, which makes a particular one not 100% suitable. Okay, one not 100% suitable. I didn't say that not suitable, but I said not 100%. Now, maybe this one can lack this one can lack the other one. Like when we talk about Wi-Fi the other day, we saw that Wi-Fi was very great. Okay, but when we have to be looking deep into this one, you're going to see another thing in this very one, that Wi-Fi was lacking. So now, because of some of these limitations, it makes some of this protocol not suitable for IoT applications. Now, one of the major problem, okay, one of the major problem that this communication protocol tends to have, number one is power consumption. Okay, number one is power consumption. Now, having a device, and then let's just say, for example, your device is being installed about 10 kilometers away from where your server or your device, where your dashboard is or whatever. Let's just say your server is installed very far away, like 15 kilometers, or let's just say 30 kilometers. That's like a small city. That's more like a small city anyway. So now, and then these things are powered. Okay, most of them are powered. So either you include a battery to it, or maybe you attach a solar panel to it. Now, if they consume power too much, you will not be able to get what you want out of that particular project, because at some point you'll be having some downtime, okay, because of power. And then you have to maybe drive down to wherever the device is, and then replace the power, or maybe at some point, okay, you may be having some downtime, okay. And then that's the number one problem. And then the next problem is the coverage, okay, the coverage, or bandwidth, or range, okay, if I'll call it that way. So let me call it the range, okay. So how far can these things travel, okay? what would be the distance? Okay, what is it in kilometers or in meters, or how can they travel? How can they travel? What's the longest distance they can take? So these are one of the problems that IoT devices, okay, communication protocols have. So now there are a lot of IoT communications like the Zigbee. Zigbee is also a part of communication. The BLE, that's Bluetooth low energy or low power. The Bluetooth is there. The Wi-Fi is also there. Okay, and other range like 3G or the LTE. Okay, now the Bluetooth, if you talk about Bluetooth has a very short distance. Okay, the range is very small. Zigbee, the same thing. You talk about Wi-Fi. Wi-Fi is just very short. Okay, Wi-Fi doesn't. The distance is not that great. And then when we talk about 3G and LTE, yeah, they're able to cover some good distance. But LTE and 3G, oh, they consume power a lot. Okay, they consume power a lot. And then there's something I always talk about them. I always say that they are hunger for power. Okay, they're hungry for power. So they're power hunger. So anyway, so that's how I do talk about them anyway. So and then but the LTE and 3G tend to give some coverage, okay, than the other ones. All right. So, but when it comes to other protocols, they have issues with power. So now that brings us to what that's because of the problem. Okay, that brings us to what we are having today. All right. So in today's class, we'll be talking about LoRa Wan and LoRa Wan technology. Okay, so now LoRa itself stands for this word now LoRa stands for long range. Okay, so let me bring up my pen. Okay, so this word now, okay, LoRa stands for long range. Okay, um, so it's communication technology, okay, which combines ultra low power consumption. Okay, like the power consumption of LoRa of this particular technology is very low. So it combines an ultra low power consumption with an effective long range. Okay, so though the range somehow depends on the environment and possibly maybe obstructions. Okay, when I talk about obstructions, I'm talking about line of sight. Okay, so for example, you have like buildings, okay, tall buildings in between the device and the gateway it's communicating to. So there may be a little there may be a little delay or something, but this device it has a very long range between 13 kilometers to 15 kilometers. So it takes from 13 kilometers to about 15 kilometers. So that's like an intensity, just like I said, it's like an intensity. So with different environments, they have different frequencies in which they run. Okay, and then this particular technology, the LoRa, is designed by the Semtech. Okay, it's designed by Semtech. So they're the ones who designed this particular device. So this particular device. So it has a whole lot of things, and then it's able to do some stuff. So LoRa is a wireless modulation technique derived from derived from a strip spread spectrum. Okay, so let's just take this word first. Okay, let's take this very word on the line there. That is strip spread spectrum technology. So it encodes information on radio wave using strip pulses. Okay, similar to the way dolphins and bats communicate, BAT uses ultrasonic. Okay, BAT uses ultrasonic anyway in order to navigate at night. Okay, so it uses ultrasonic to navigate at night. So they send out waves. Okay, they send out waves and then they receive those waves and then they make an action towards that. So now the LoRa modulated transmission is robust against disturbance and can be received across great distance. Just like I said, it ranges from like 13 kilometers to about 15 kilometers. So the distance is very, very good. So now there are things I would like you to look at here in this very thing. Okay. Now in this stuff, I'm talking about the terminologies that are being used here. Number one is the shift spread spectrum, and then also the LoRa modulation. Now, talking about the spread spectrum. Okay, so it's a digital communication. Okay, it's a digital communication. So it works under a spread spectrum technique that uses wideband linear frequency modulated strip pulses to encode information. Okay, so a strip is a sinusoidal signal. Now its frequencies increase and decrease over time. Sometimes it's with a polynomial expression. Okay, for the relationship between that time, it's sometimes it's just a polynomial expression between the time and the frequency. So now it uses an ultra wideband, okay, protocol network. So which is for precision, okay, ranging from a low rate wireless network to maybe in a 2.45 gigahertz band, okay, upward, it just ranges like that. So but it was released under it was released I think the IEEE, okay, released it, and then under the 802.15.4E. So I think it was released on around I think it was released around that. So that's just basically what that particular stuff is. Okay, so now this spectrum helps, okay, to helps to encode information, okay, and then the way the frequency goes up and the way the frequency comes down, that helps that makes it easy for it to be able to communicate. Now it somehow works under the frequency shift key, okay. So I don't know if you've heard about that, the frequency shift key. So it somehow works with that. So it's very, very useful when once you talk about LoRa, there's no way you can talk about LoRa without LoRa without the spread spectrum. Okay. So now when we talk about the modulation here, it's just the way in which this information, all right, just the way this information is being able to this information is being encoded and decoded, okay, how these informations are passed from one particular place to another, and then that falls under the spread spectrum technology anyway. That it just falls under that. So which has to do with it has a particular formula which has to do with the spread factor anyway. It has a formula with the spread factor anyway. That is SF. Okay, so that's just basically for that. And then I'm going to drop some more information regarding this on the channel. So let me see if I can make some time. Okay, so looking at this, we need to also know what LoRa Wan is also about. So LoRa Wan, when the other day when I was talking about Wi-Fi, and then I talked about the mask, okay, when I talk about remaining the media access control, which is a protocol layer. Okay, so this LoRa Wan is built on LoRa. All right, so without LoRa, you would not really have LoRa Wan, because LoRa Wan is built on top of LoRa. So the LoRa Wan is a MAC layer protocol, okay, which is built on top LoRa modulation, okay. So it's a software layer which defines how device use the LoRa hardware to communicate. All right. For example, when they are transmitting information, the format in which they are transmitting, when they are receiving, the format in which they are receiving, and as the case may be. So it's a protocol. So the LoRa protocol was developed and maintained by the LoRa Alliance, okay, and it was first released around January 2015. That's when it was first released. So if we want to talk more, if I want to talk more about the LoRa Wan, okay. So I'll say that since the LoRa defines a lower physical layer, okay, and the upper networking layer, okay. So I'll say that LoRa Wan is one of the several protocols that we developed to define the upper layer of the network. All right. So LoRa Wan is a cloud-based medium access control. Okay. When I talk about that, this media access control. So it uses MAC, like I said. So, but it acts mainly as a network layer protocol. Okay. So subsequently, we're talking about the 7 application layers of the OSI. Okay. So we talk about the 7 layers of the OSI. So we'll talk about that later. So now, this LoRa Wan acts mainly as a network layer for protocol, kind of layer protocol for managing communication between the LoRa gateway and the end node device. When I talk about the end node device, I'm talking about the devices in which they are the ones transmitting, the ones that are measuring the physical quantities, they're the ones that are in your gadgets. Okay, those are the ones I call the end node device. Okay. Now, so it actually kind of like maybe as a routing protocol. Okay. So the architecture, the system of LoRa Wan and architecture, okay, for this particular particular network is on the physical layer. All right. So which enables long range communication. All right. It enables long range communication. So LoRa Wan is also responsible for the managing of communication frequencies, that is data rate and the power for all the devices. Okay. So now the device in the network are kind of asynchronous, okay, and they transmit when they have data available to send. Now, take note of that. Now, they transmit when they have the data available to send. So when they are not, so when they don't have data available to be sent, most times they go on a sleep mode, okay. I talk about sleep mode when we're dealing with Wi-Fi. So when they don't have data to transmit, they go on a sleep mode. So they only transmit when they have data available. So now the data transmitted by an end node, okay, device are received by multiple gateways. Okay, so maybe you're using maybe a stack of have the place or whatever protocols you're using, or whatever networking protocol you're using. So it is received by multiple gateways. Okay. Now, once they receive by multiple gateways, now this gateway now forward the data package to a centralized network server. Okay. So this network server can be maybe in a remote environment or whatever. Now, data are often forwarded to the application server, and the technology shows high reliability for the moderate load. It also have some performance issues, which we are going to talk about later on in this particular class. It also have a lot of just few performance issues. Now, the reason I talk about this is that remember when I talked about, I said that there are a lot of communication protocols, but some of them have little one or two issues. So this one is all about that. So now the LoRa Wan is under something called the or something I'll call the LP1. Now the LP1 stands for Low Power Wide Area Network. All right. So the low power wide area network is a type of wireless telecommunication network that allows connected devices to have long range communication capabilities. No, at its at a low bit rate. Okay. So now the LP1, okay, that is the low power wide area network, is used in most asset monitoring and management in smart cities, or maybe industrial Internet of Things deployment. When I talk about industrial Internet of Things deployment, I'm talking about IoT deployed in industries. Okay, maybe for example, where you have places where humans cannot really go into, so you just go into to get readings or do some action. So yeah, they are deployed in that particular environment. So it's also it can also be used. It's used in most corporate, large corporate organizations anyway. So now, like, remember when I said that it has very long range. So it has an operating range up to 10, like 13, 15 kilometers, depending on how it works. So because it is of low power, okay, because it's of low power, now the battery tends to last very, very long. Okay. So when they are transmitting, some of like the very one we'll be looking at today, like when it's transmitting it's consuming power at a rate of 4.5 milliamps. So very small, okay, when it's transmitting power. So you can put a good size of lithium ion battery into it, and then it's going to take a very long time before that battery runs down. Like, you don't have issues. So you will be having issues of downtime, because before you have a downtime, it's going to be like a very long time. Like, you'll be because of this low power ability. So batteries inside of it tends to last very, very long. So like, I think there was an article that I saw that said that some of them allow batteries to run up to 20 years. Okay. Now this depends on the type of battery, okay, that is installed, and how the bit, okay, the type of class that particular device is. So we are going to see, when I'm going to talk about the classes later, because we have different classes of LoRa Wan devices. So it depends on the type of class in which it operates. Okay, some of them consumes a little bit more than 4.5 milliamps. Okay, so there are some that consume less than that. There are some that consume more than that. Anyway, so but in the whole sense that it's of low power. Because it's of low power, you can compare it to things like Wi-Fi. Okay, Wi-Fi, yes, it's good. Okay, we're going to talk about the I'm going to compare the two of them anyway shortly. I'm going to talk about them in terms of frequencies and bandwidth anyway. So now, talk about the spreading factor, like I talk about. So the spectrum technology uses the strip, okay, just like I talk about, which are signals with a frequency that moves up and down. Okay, so we have the upstrip and then we have the downstrip respectively. So, and this upstrip and downstrip move at its own speed, at their different speed. Okay, so so now the spreading factor, now the SF determines the speed of that particular strip. Okay, so a higher spreading factor means a broadcast has higher range and higher penetration. Okay, it has the ability to penetrate like obstacles and then goes. So now remember I said that there are some that has up to 15 kilometers. Now, when once you have some device, some structures, okay, in between the end node and the gateway. So you tend to have that, or get to say that it no longer transmit that it tends not to transmit that far anyway because of those obstacles. So at free space or eyesight, it tends to transmit very, very far. You're talking about kilometers, like tens of kilometers, depending on the type you are using anyway. So now this spreading factor, the higher the spreading factor anyway, it means the broadcast is going to be the broadcast has a higher range and a higher penetration. So now this cost, okay, also the cost of this spreading factor can also affect the power consumption. Okay, the way the way they're able, the higher the penetration and the range, it somehow affects the power consumption. So it tends to consume more than if it's low. So a lower spreading factor is faster and transmits more data at the same bandwidth at a particular time, at a particular time anyway. So that's just a little about that. So now the end device, okay, which are connected to the LoRa Wan technology, okay, kind of communicate in two ways, okay. Number one is what I call the OTAE, which means over the air activation. Now, over the air activation, the device has to establish a network key and then an application session key to connect to the network, So that's why we call it. That's why it's being called the over the air activation. That means it needs two security. That is the network key and the application session key. I'm going to talk about that in depthly in the next in other slides. Then the next way it works is by activation by personalization. Okay, it's ABP. Okay, activation by personalization. So now this device is now hard coded with a particular key. Remember when I talk about hard coding in Wi-Fi with ESP, I said that okay, when you're hard coding like SSID and password, like and that means anytime you want to change it, you have to open the code again, connect it to a laptop, and then write the code again and all those stuff. So when I talk about hard coding, that means in the program you have to include the key. All right, you have to include the key in the program when you're writing that. So the device is hard coded with the key, which the key that is needed to communicate with the network. Okay. Now it somehow makes it less secure, but it kind of has an easier connection anyway. It somehow makes it less secure, but it kind of have high an easier connection. All right. So now let's look at the bandwidth and the range. Okay, just look at this particular graph in here. Now you have seen LoRa Wan. There's LoRa here. There's LoRa here, and then you have Bluetooth. You have Wi-Fi. You have some video, voice, consumer IoT, other IoT devices up here. You have the cellular network up here, which has to do with maybe 3G or 5G or whatever frequency in whatever bandwidth you're using. Now, the Wi-Fi and Bluetooth, okay, tends to have a higher bandwidth, okay, but tend to have a short range, okay. It doesn't really have a long range, okay, but they have a very high bandwidth, okay. Like I said, sometimes like I said in the last class, up to Wi-Fi 6, okay, up to Wi-Fi 5, and then which have the ability to transmit up to 5 or 6 gigahertz, okay. It doesn't have a very long range, okay. So for example, like when you turn on your router at home, and then maybe you're living in a story building, when you get downstairs, you end up not having your signal start going down. And when once you get to maybe the last floor, maybe of a 3-story building or maybe a 4-story building, before you get to the ground floor, you tend not to have signals anymore. So yeah, the frequency, the bandwidth is great, but the range is very short. So, and even with that, having a very short range, it also tends to consume power a lot. Like when we talk about the ESP, we saw the power it was consuming. I sent you a chart on the Slack channel. You saw the power in which it was consuming. So if you need a device that needs to stay long, okay, before power goes off, okay, you need a device that needs to stay for a very long time before power is off. You may not really need this. And then if you also need device that can do that needs very long range, Wi-Fi will not really be needed. Okay, so looking at cellular network tends to kind of have a high bandwidth and a good range. Okay, cellular network has a high bandwidth and a good range. But the thing about cellular network is about power. Okay, cellular network consumes a lot of power. Just I'm going to take a very specific example. Okay, how many of you, just give me a thumbs up if this is true with you. Okay, how many of you, when you turn on your when you turn on Wi-Fi, okay, or when you turn on internet on your phone, like you connect your phone to internet, when you turn on data on your phone, your battery tends to run fast. Give me a thumbs up if it happens to you. When once you connect your data, you just turn on your data, your battery tends to run fast. Yes, it happens to me. It happens to me a lot. Like when once I turn on my internet, my battery tends to run very fast. Yeah, that's because that's the protocol in that's how cellular network works anyway. So but once you turn on your internet, yes, it consumes power a lot. But coming to LoRa, okay, coming to LoRa here, LoRa doesn't have a high bandwidth, okay, but LoRa has a very good range, okay, compared to all of them. Doesn't have a great bandwidth too. Doesn't have a great bandwidth like cellular network or maybe Wi-Fi, okay, but it has a very good, very good range. Like I mentioned, up to 15 kilometers. So 15 kilometers is just like the city of a gate. So you may not need a third-party device because now once you're connecting your device to a cellular network, you know you need an ISP, okay, a network provider. Hope you know that. Maybe likes of MTN, likes of Glo, likes of Airtel, likes of Satellite. You need an ISP to give you internet, all right, to give you access. So now that's cost because you are going to pay for that coverage they're going to give to you. You're really going to pay for that coverage they're going to give to you. So that's cost anyway. So with LoRa, because of its long range, you don't need to connect to maybe a third party. You don't need a third party provider to give you access. You don't need a third party provider to give you access. You can just connect to your device, just connect directly to your device, and then off you go. You don't have issues. You don't have issues at all with that. So that's a good thing about LoRa anyway. So it doesn't have it takes long range, okay, very good long range, and then doesn't work with doesn't consume a lot of energy. Okay. So let's proceed. So now, how do this device work? How do LoRa Wan work? Okay. So you might be seeing a whole lot of things. We've talked a lot about this thing, this particular LoRa Wan, the thing. How do this really work? Okay, what are the means, okay, in which they communicate with each other? Okay, how is the data being transmitted? All right, so now I'm going to divide these into different modes. Okay, so I'm going to divide this into the first section is going to be this. Okay, so I'm going to divide this. This is going to be the first section, and then we're going to have the gateway, which is going to be the next section that I'm going to talk about, and then we're gonna have the network saver. Okay, I'm going to talk about the network saver, and then I'm gonna talk about the application saver. All right. Now notice one thing. So that you don't have an issue. Okay. Notice one thing. You have TCP and IPSSL here. You have TCP and IPSSL here. So they also work with payload. Okay, they work with payload, and payload. I'm talking about the date, what you're sending, what you're receiving, and then talk about transition control protocols and IP protocols. It works. It works also just like Wi-Fi and just like the way Wi-Fi works anyway. So when we go deep into protocols, we're going to deal in depth on this TCP and IP. Yeah, I told you that in the last class. Okay. So now let's talk about the node devices. Okay, like the node device or the A node. Okay. So now this A node these A nodes are sensors, okay? These A nodes are basically sensors or actuators, okay? At the edge of the network, just at the network edge, okay? They are basically maybe when I talk about actuators, maybe something like relays, some things like breakers, some things like thermostat, some things like humidity sensors, whatever thing you have, maybe an LDR at the end of it to check for whatever you want to check. It can be anything, okay? It can be anything, all right? It can be anything anyway. So these are just basically the device at the upper at the end of at the edge of the communication anyway. So it can be anything you want to work with, anything you want to transmit, and all those things. Okay, so you don't really have much issues with this. So maybe it can be your GPS device. Okay, maybe your device that checks GPS. Okay, it can be your device that checks maybe whatever, maybe temperature of a particular place or whatever stuff. So maybe checking the maybe if you're having maybe it's for agriculture, okay, maybe you're using it for agriculture, maybe the water level, okay, on soil, or maybe your nutrient level, okay, on the soil, or maybe some other factors like that. Maybe you're checking for, maybe you're using it for medical, maybe for heartbeat, or maybe for other things anyway. So it depends on whatever you're using. So it just whatever you're using at the other part, okay, to send information, okay. So this can be anything at all. It can be anything at all. Anything, I mean anything. So, or maybe it can be your speed device checking the speed of your speed of a particular thing. Okay. So now this end device serves different applications which have different requirements. Okay. Like you see here, you have gas. You have the gas monitoring here. Maybe checking for gas. What type of gas is there? What type of gas are you emitting or whatever? So, or maybe you're checking maybe a vending machine, or checking maybe a vending machine, or a trash container, or maybe just for example, this is one of the projects. Okay, I tried to this is one of the projects I tried to people some time ago, and then if you want to work in that particular, if you want to work for that particular project, you can just let me know. Just drop it on the Slack, then I'll add it up. So using LoRa Wan, we have like in apartment state, we have different trash cans littered all around. Okay, so why can't we? So we started working on this particular project. So it's just like this trash can is just to attach sensors to each of those trash cans, so that we don't need to use Wi-Fi. We don't need to use that. We don't need to use Wi-Fi at all. So we just need to work on that, so that they can know where a particular dustbin needs to be taken out. Okay. So there are a lot of stuff anyway. So you can use that for a trash can, and then water meter. Like for some countries that water is being metered and everything. Not like Aquabum here, which a fiber here or a case here, which everybody has their own maybe water system at home. Okay, so smoke alarm or maybe pet tracking. You want to know where your pet is, a dog, a cat, or wherever. You want to know where they are. You can just design a little sensor that track their location, then attach it to their neck, and then you can use to monitor them. So it serves different applications. The different applications. It's not one thing. Different applications. Where whatever applications you want to use for numerous applications. When we talk about the application, I'm going to list something. So now, like I said, they have different requirements to work it out. So maybe for gas monitoring, you need there are different requirements for gas monitoring. There are different requirements for for trash container, vending machine. There are different. So now, in order to optimize the variety of the end application profiles. So now, LoRa Wan utilizes 3 different classes, which the end users can be configured at. Okay, I'll talk about classes. So let me use this opportunity to talk about that. I'm going to come back to the rest of this. So now these classes are the class A, the class B, and the class C. All right. So the class A are bidirectional, okay, end devices. All right. Class B devices are bidirectional end devices with a scheduled receive slot. Okay, it has a scheduled receive slot, and then class. Let me just let me just move there. I put that up. Okay, so these are them. So they have a scheduled slot. Okay, that's for the class B. Then for the class C, which is the third one, it's bidirectional end device with a maximum receive slot. So when I talk about maximum receive slot, now you can see that some of them, okay, they have different ways in which they speak with each other, different ways in which how they transmit to the gate. Okay, so when I talk about the gate, I'm talking about this. Okay, so this is the gate. Okay, this is the gate width. All right. So I'm going to come back to this particular slide. So let me just talk about other ones. Okay. Let me just talk about other ones first. So now, this very one, okay, the class A now has this. Okay, class A has this. So now it has an uplink time, and then it has a time in which it transmits, and then the time in which it do not transmit. Okay, just like remember I said that the class A are device that requires a downlink communication. So now when I talk about the downlink communication, I'm talking about when they are receiving. Okay, receiving is the downlink. Uplink is when they are transmitting. Okay, uplink is transmitting. Receiving is the downlink. All right. I hope you're good with me. All right. Okay. So it has an implementation. Okay. So the class A is always initiated by the end user, okay, the end device. That is this very device here. Okay, so it's always initiated by this very device. That's the class A. All right. So they are the ones that schedule when to receive information or when to receive information or when not to receive information. Talk about these devices in here. All right. So it's being initiated by commission is always initiated by the end device. So now a device can send an uplink message at any time. So once the uplink transmission is completed, the device opens 2 ports. These are the 2 ports it opens. All right, it opens 2 ports. Okay, it opens 2 ports. All right, these are the ports it opens. So once the uplink transmission is completed, the device opens it opens 2 short ports for receiving. Okay, which is the downlink. At this point, it's receiving now. So now when it open this downlink window, okay, there is a delay, all right? There is a delay between the end of the uplink transmission and the start of the receiving window, okay? So this the delay I'm talking about, okay? So for here you have this and for one, okay? So it has two delays, okay? This delay comes in immediately after the uplink. That means immediately after it has transmitted something, okay? So receiving, there's always a delay between the uplink and the downlink. So we want to open that port for two short receiving windows relate delays there that just that holds it down. Respectively, you can see that the delay from the uplink to receiver one is different from the delay between the uplink and receiver two. Okay, these delays are different. Okay, so the delays are respectively. Okay, so now if the network server does not respond during these two receive windows, the next uplink will be after the next downlink will be after the uplink transmission. So if there is any a failure, okay, in reception at when these two receiving windows are created, the next reception that is going to come is going to be after another, because after every receive, after every uplink, you have a downlink. After the downlink, you have an uplink again. Then after that uplink, you have a downlink. So that's how it goes. It's kind of so it fluctuates uplink and downlink, uplink and downlink. So when once in class, when once it misses that period, that first period of the first two windows created, the next reception is going to be after the uplink. Okay, that's going to be the next reception is going to get. So now the server responds during the first the server response can respond during the first receive window, that is that's the receiver window, that is the receiver 2. Okay, but this use both windows. Okay, they don't use both windows. All right, they're just how will I call it? They're just independent. Let me just use that word independent anyway. They're just independent. So they don't use both windows. All right. So for example, let's just see maybe some conditions. All right. Let's just see some some conditions about these. So for example, you have like 3 conditions. Okay. You have like 3 conditions. Okay. You have you've seen 3 uplinks there. You've seen 3 uplinks. You've seen 3 you've seen other receivers there. So let's just name this one. Let this be a test 1. All right. Let 1 be a test 1, and 2. Let this be a test 1, and 2 be a test 2, and then 3 be a test 3. All right. So let me just try to explain these respectively. Okay. So please, if I'm still audible enough, please just give me a thumbs up so I know I'm audible enough. Please, if I'm audible enough, just give me a thumbs up so I know I'm good enough. Okay. All right. All right. Please, if you also have a question, okay, I'm looking at the chat. Please just drop your question at the chat, and then I'm going to respond. So now, let's just give this case 1, case 2, case 3. Okay, example, and then let's just take the first case. So now the first case being this very case 1 now. All right. Okay, being this very case now. Now the end device open both the receive window, but it does not receive the downlink message during either windows. Okay, it opens 2 receive windows. Okay, it opens both receive windows, open this receive windows and this receive windows. Okay, but it doesn't receive the downlink during each at either windows. Okay, so this for this very one. So now this window is open, this other window is open. There are going to be delays, okay, between this and the delay. So this one is going to receive first before this very one receives. All right. So let's just say some devices in a particular node. Let's just say node A. Let's just say a node A, which has to check which has a kind of camera that counts how many vehicle that that passes in a particular place. Okay. So what happens is that it counts and then upload that information. That's the upload, not transmit. So now, when assuming that we need to make a decision after some vehicle count, there should be an action. Let's just say in the case of a traffic light, maybe after some vehicle count, there should be the red light should come up. Okay, waiting for another vehicle to come up. So now, this what happens. It's going to open to Windows. Okay, it's going to open to Windows, but there's going to be a delay. Okay, between the first window is opening and the second window is opening. Okay, and either way, they're not going to receive simultaneously. There's going to be delay at some point receiving when there is receiving a downlink from maybe the server. Receiver one receive a downlink from the receiver, or the receiver two receive a downlink from the receiver. So that's how this case one is all about. So now case two now. All right, let's talk about case two. Now case two is when the device now receives a download message during the first receive window, and therefore it does not open the second window. All right. So this one it has just one receive window. Okay. You don't see TX2. All right. So at this point, it only have just one delay. Okay. So whenever if any message should miss this first receive window, it has to wait. There's no other one. There will be no other window for it after till the next after the next uplink. Okay, that's when the next window is going to happen. So now case three here says that the device opens both windows. Okay, the device opens both windows, but open the first receive windows, but does not receive a downlink. Now, therefore, it opens the second window and receives the downlink during the second window. So now this one is going to open the first window here, but doesn't receive the first doesn't receive a downlink. Okay. So because it didn't receive a downlink, it open another window and then receive the downlink. So that's how class A device somehow works. So one of the things about this class A, some of the things about this class A is that one of the things you need to note about class A is that they are often battery powered. Okay, they're often powered by battery. Okay, class A devices, they're often powered by battery. Okay, and they have the lowest energy consumption. Okay, they have the lowest energy consumption. They don't consume much. They have the lowest energy consumption. They tend not to consume much. Please mute yourself. All right. Then there's another thing you need to know about that is that about class A devices, that they spend most of their time in sleep mode. Okay, they spend most of their time in sleep mode. They only come active when there is a data to send. When there is a data to send, that's only when they come active. And after that, they go back to sleep mode. So once there's no data, they go back to sleep. Their batteries tend to last long. Okay, batteries of class A tend to last long. Like some of them, like I said, can last to close to 20 years. Okay, before you do the replacement. That's if you put a, then it may take up to 20 years before you make a replacement. If there's no data to transmit, it will just all go on sleep mode and then wait till the data to transmit. So another thing to note is that it usually keep long intervals down. Okay, uplink. Okay, So they are going to be a long interval because of this delay. Okay, because of this delay, it's going to keep those intervals because of those delay between each uplink. Because after the first uplink, there's going to be a downlink before the next uplink comes up. Okay, so it have a high downlink latency. Okay, so that means to receive a download, okay, so the end device must send an uplink before it can receive a downlink. Okay, and some of the cases of class A end device is that for environmental monitoring. I made a very case example, a very case with the trash can, okay, the trash bin, okay. I made a very good example with the trash bin. So another one is animal tracking, okay. A one of us, okay, one of our partner, I think is develop one of our partner is developing very big technology which is LoRa Wan in tracking. So I'm not going to reveal that now till maybe some of you are very good with what you're doing now. So some of you will be working with that project anyway. So another the fire detection, okay. These ones are mostly only in some countries, okay, where you don't need to be transmitting, you need a third party, so it's just the transmitting to the fire service. Okay, when there is an outbreak, so when there is an outbreak, it will sleep and stay there till maybe there's an outbreak, and then you just wake up and then send it to the fire station, and then fire service for them to come and then help things out. Then the next one is linkage detection, earthquake detection. Earthquake detection, you don't want some random when you when there is a real, like when there is a good data. When there's a good data, what I mean by a good data is that when there is a change from previous data, from the previous data, that's when that's what I call a good data. Okay, when there is a change between previous data and the current data, so it's not, so you don't end up repeating one particular data over and over again. So assuming in 7 years, keep sending one particular data from now to the next 7 years before you're able to before you get something at all. You won't take it serious anyway. So when you have a change in data, that's when you need to take an action. So another one is location tracking. So for example, you're in a very big industry, so you want to know where things are, where assets are how assets are being moved. Okay. The first batch of a particular product are done, okay, and that been manufactured, and then there is a track, there's a device actually. So you can see how the products move from one department to another till it gets to the warehouse, or till it gets to the store, in which it has to be where it to be sold out. So these are some of the common use cases of the class E. So now moving down to class B device. Let's talk about how class B device works. So now class B device are not that as complex, okay, or maybe are not they're different from class A anyway. So now although they have some similarities, because when I'm talking about the similarities, I'm talking about this delay, okay, between the uplink and the receive, okay. So though they have some similarities because of this delay with a class A, so the class AB device opens a schedule receive window. Okay, so its receiving window is scheduled. Okay, so it opens a scheduled receive window for receiving downlink message from the network layer. So it can be saying like for example, every source of hours, okay, that's gonna be receiving, okay, that's gonna be going to be opening the port for receiving. So it's scheduled, it's timed, okay. So when it gets to that point, it's open and then knows, okay, at this point there should be another data coming in. So it opens that the asset, open access for data, and then after that just closes that up. So the class B has a scheduled system, okay, when it comes to receiving, okay, it's scheduled anyway. So it uses time synchronized beacons to transmit data, okay, by the gateway. All right. So now this device periodically opens to receive windows. Okay. Now the time between two beacons is known as a beacon period. Okay. Now when I talk about the first beacon, okay, I talk about the first beacon here and the next beacon over here. All right, that's what is known as the beacon period. So it's the time between the first period, the first beacon, and the next and the last beacon. So that's or the next beacon, yeah, is the beacon period. Now the device opens the uplink, okay, a downlink. So some most times call it a ping slot, okay. Now when I talk about a ping slot, okay, or for example, you just open a terminal and then do a ping, okay, maybe ping www to see how you're able to send data and receive data, how you're able to send and receive data. So that period, maybe you do a maybe ping www.google.com, okay, and then hit enter in your terminal. At that point, you're sending an uplink, okay. So now when it will be sending you IP addresses of IP addresses, the submax, and then the MAC address of what is coming down, those are the downlinks, okay. So the ping now is like if you like sending out a trigger, or let me just call it a trigger, or sending out something, okay. So we want to send out something at that point, okay, you're ready for a downlink to come another clock. So it sends out a ping slot, okay, at the scheduled time for receiving downlink message, okay. So remember I said that before you have a downlink message, there must be an uplink first, okay. So it sends out a ping slot for receiving a downlink message from server. So now class B devices also open receive windows for sending an uplink. Just like you can see here, it's open windows. These two windows, it can open two windows. Okay. So now the class B device have lower latency, okay, than the class A. All right. So it has lower latency than the class A devices. Now this is because they are kind of rechargeable, okay. They're kind of reachable at pre-configuration. They're kind of reachable at pre-configuration, and they do not need to send an uplink to receive a downlink. Okay, so sometimes they just because of the ping and the beacon there, they don't necessarily need to send an uplink before they can receive a downlink. So now the battery life is shorter in class B than that of class A. Now, because of this, okay. So it's shorter in class A. The battery life is shorter in class A than the class. It's shorter in class B than class A. Why? Because of this periodical downlink, okay. It tends to consume. It wakes up to consume data. So let me just take this through, okay. So just for example, I have what's my thing? I have a device here, okay, which is of a class of A, okay. And then I have another device here, which is of the class of B. All right, and then this one, okay, let's say for example, we have an intruder alarm. Okay, let me just use a case. Let me use a case, a very like a good case now. We have like an intruder alarm. You want to check when someone breaks into a particular apartment. All right. So now this class A is going to wait till there is there is a data to be sent. Okay, that's when it will wake up and then send a data. Or let me just say, okay, let me just put it that way. Let me just put it that way. So there is a change in data, okay, between the previous data and the current data. That's when it knows, okay, there is a good data, and then wakes up from sleep mode and then send the data. So for example, let's just say before, let me just say, Phoebe, someone is to break into a particular apartment, maybe after some, we don't know the time, but it always takes a very long period, okay? And we do not know this particular time. So what happens, you can set this off, you can set up the class A, okay? And it is going to be on sleep mode till someone breaks into the apartment. The class B will always want to wake up at some interval, okay, depending on how it is pre-configured. It needs to wake up at some interval to send you data. So that time it wakes up to send you data, it's consuming power, while the other one is still at sleep mode. Okay. So till when the maybe an intruder finally breaks into the apartment or something, that's going to send you another. So most times it fails though. Most times because of this scheduled process so it has, it sometimes needs, okay, like maybe for example it was to send you a data in the next 2 hours, and then before that 2 hours something happens. It has to wait till that time comes before it sends you a data. So sometimes it needs anyway. It do miss sometimes anyway. So, but it's still useful. So so another reason why it consumes data more than the class A, just like I mentioned, is that it spends more time in it spends more time in mode. That's this mode that during when the beacon and the during the beacon and the ping slot when they are making some stuff. So now one of the use case of this class B is the utility meter, like the prepaid meters we have around. Okay, I'm not going to tear down the protocol that is behind it. Okay, so I'm just going to just leave it there. So it's used in the utility meter, like in the prepaid meter here we have in Nigeria. Okay, then maybe temperature reporting and other stuff. Okay, so that's for the class B. So now for the next one called the class C. All right, the class C. The class C here is the class C here tends to be a little bit different. Okay, now the class C device extend class A, it extend class A anyway. It somehow looks like class A, but it have more than one receive window. Okay, so now the thing is that it keeps the receive window open unless they are transmitting. Okay, so it keeps this transmit window open like this. I keep this this receiving windows open. It doesn't close it, just keep this receiving windows open. It's constantly receiving, except okay, it's transmitting. So it's constantly receiving things. It's only when it's transmitted that's when it will close this and then open an uplink or transmit and then come back, open up the thing. So it allows for low latency communication, but is many times more energy consuming than class A, okay, or class B. Consumes more than class A, consumes more than class B. All right. So that's for this particular class C. So so most of the time it uses, okay, most of the things it's being used, this class C is being used for often they're often main powered. Most times they don't use battery or whatever. They're often main powered. Maybe sometimes they have to attach maybe a solar panel if it's at a very remote environment. You may have to attach a solar panel to it for you to be able to get the information you want at the time you want. And then it can the downlink it doesn't most times doesn't have a downlink latency, so because of its continuous receive windows. All right. So there are some of the device in which they are used. Okay. Now some of the devices in which they are used are the cutoff valve or breakers or street lighting. Okay, those are so that's some of the applications of the class C. All right, that's some of the way they are being the class C is being used. So that's with this, I think I've been able to talk about these end devices. I've been able to talk about these end devices. So now let me move to the gateway devices. Okay, let's talk about the gateway devices. So now these gateway devices, hope I'll be able to finish up this. So now these gateway devices, they are also referred to as concentrators. Okay, that's why you see me putting concentrators on top. They also refer to as concentrators. So now they are device connected to the network server via maybe a standard IP address. Okay, all right. They are connected to the network server. Okay, these are the ones that are connected to the network server, and these are now the end node. Okay, the end devices connected to them. So this can be your router. Okay, this can be your router at home, whatever ISP that is being. ISP that is being that has been working on. Okay, so this includes your router. Okay, so but it has its own radio frequency. Okay, so most of them that has their own radio frequency, I'm going to show you some of them that have their own radio frequency. You don't need to like go get something that doesn't really work anyway. So this one has their own radio frequency. So it's connected to the network server via standard IP connection. Okay, so now this message between the central server backend and the end user using a simple simple hop, okay, or a simple hop wireless communication protocol. So this is what relays the message, okay, from the central server, okay, or maybe for example wherever your server is, it won't release your message from the central server to the end device. So maybe it can be this can be maybe your dashboard. Okay, let's just say it can be your dashboard or something, whatever. So the backend in which most of some of these things your dashboard is being connected to. So the message that comes out of that backend, okay, so it goes through the network server to the gateway to the end device. So it's like will I call it a mediator? Well, I don't know call it a mediator anyway, but it's a concentrator. It's bidirectional. Okay. At the same time, it's picking information. Okay, it's picking data from the end device to the backend, and also picking data from the backend to the end device. So it's bidirectional. Okay. So now they are assigned to support bidirectional communication. Okay. and they are equipped with multicast enabling multicast enablement, okay, that enable the software to send mass distribution messages to the device. So it can send like lots of messages. So it can send like lots of messages to the end device. So now the heart of every LoRa gateway, okay, is a multi-channel LoRa demodulator that is able to decode all LoRa module variants, okay, on different frequencies in parallel. Okay, so this is not like a serial communication protocol that you have maybe that uses maybe a first in first out technology or a last in technology. This one runs in parallel. I would say in to some context that it's simultaneous, like decodes those frequencies simultaneous to some context or to some extent. Okay, so now but for a very large scale network operators, okay, now the key distribution factors, okay, should be the radio performance, that's the sensitivity and the sending power of this gateway, okay, that's sensitivity and the sending power of this particular gateway. So there is this particular chip called the SX 1301 chip, okay, if I'm not forgotten. I think I'm right. That's the you can check this particular chip out. That's the X X 1301. Okay, 1301. Okay. So it uses a microcontroller, okay, and this microcontroller or the microcontroller supports USB, support kind of support USB to SPI, kind of support SPI to SPI. It supports a lot of things anyway. So now the support and the distribution of this particular gate signal, okay, whose has to be available. No, it must have its availability, and then it must be very precise in terms of time synchronization over the entire gateway. So it should be able to send things in real time and just that. But this particular chip, okay, but I think this one thing between the end device and the gateway across the multiple frequency channels and data how to use uh, for these. Okay, so condition form. So a different data rate in which they transmit and different frequencies in which they. So now the spread the spread uh 0.3 kilobits kilobits per second, 0.3 kilobits per second, so about 50 kilobits per second. That is really good. Okay, that is really good. Like I want to compare like 5G, which has ability to transmit more than 1 megabit per second. Well, this is just this is low bandwidth, so it doesn't really take higher that great bandwidth. Okay, the very good anyway in terms of the speed in checking. So from 0.3 to about 50 kilobits per second, it's good. So now this prevents this particular speed now is to prevent communication from interfacing with each other. Okay, so this communication doesn't interfere with this one, doesn't interfere with this other one. They're all the communications are just separate. All right. Okay, so all the communications are just separate. So you there's no interference between one device or one. So really, there's something it really helps you to maximize both the battery life of the end device and the overall network capability. So it uses something called the adaptive data rate. Okay, it's the adaptive data rate. So the adaptive data rate is something that is just a protocol that LoRa uses on the network server to manage data rate and radio frequency output from one particular node device to the other. Okay, so use an data this big one here network server. So now the network server is the interface between the application server and the gateway. Okay, so it relays a command from the application server to the gateway while trying to while trying data. Okay, while trying data from the gateway to the application server. It also perform other functions, ensuring that there are no duplicate packages. Okay, so when I say that it ensure there are no duplicate packages, that if like it checks the data that was first sent and the data that's next that is sent again. If the data are the same, it just knock them off. All right, they just knock them off. So it doesn't. One thing about LoRa is that it doesn't really. When we get down into working with things with the main components, you're going to see that it doesn't really work like HTTP. It's communication protocol doesn't really work like HTTP or HTTP or MQTT, any of the MQTT broker. So it doesn't. Okay, it doesn't work like that. So it's just different, champ. So we're going to look at that anyway. So that's what the network does. Okay. So like I said, it uses adaptive data rate because in order to run some packages. So it checks for duplicate packages. Okay. It schedule acknowledgement and manage the data rate and radio frequencies output. Okay. So these is one of the functions of the in a network server, ensuring a duplicate ensure that there are no duplicate packages. It's a schedule acknowledgement. That is, if the device is of a class of B, okay, which reception has to be scheduled, okay, it's going to the network server is going to schedule that and then send those information, and then it's also manage the data rate and radio frequencies and others. So now the application determines what the data from the device are used for. Okay, the application just determines what the data that is gotten from the device are being used for. So remember I talked about the dashboard. Remember I talked about a dashboard, and then what does dashboard do? Dashboard gives you dashboard gives you a representation, okay, of values of what is happening, what's happening to the device. So it's like just like let me just use for data visualization. Yeah, let me use that word, data visualization. So you're able to see your data, how your temperature is increasing, your water flow, or maybe you're measuring maybe you're measuring how a petrol is being sent to petrol is being sent to maybe a particular machine. You can measure the pump rate and everything. So it just that application just how those data are being used. It just gives you that's just how the data are being used anyway. So that's for that. Let's see how we can use of time. Okay, so let's talk about the security of these. Okay, Is it secure? Yes, it's very secure. Okay. LoRa Wan is very, very secure. All right. So it's not like every other stuff. Okay, not like every other devices. Okay, so it's very, very secure. All right. So it uses security keys. All right. It uses security keys. Those are the ones I'm trying to align with red and blue, red and blue. Okay. So when you see red, okay, when you see red, red here just means the application. Uh, the red here just means application session key. All right. This APPSKEY means application session key, and this other NW key S key means a network session key. So what really? So let me define this term so that you really understand before we move into. So now the application access session key is used for encrypting and decrypting. Is used for encryption and decryption of payloads. Okay. So what are payloads? Payloads are basically data that you're sending, the information you're exchanging. All right. So when we talk about when we start doing IoT, when we deal with MPT, you're going to hear us talk about payload the most. It's just the information that is being exchanged. Okay. So the one you're sending, the one you're receiving. So those are your payloads. All right. So now the payload is fully encrypted between the node, okay, and the handler application server, okay. So it's very it's protected, all right, between the node and the handler application server. So now the things network, okay, which the thing so it just runs on the thing network. So now the thing is that it means that nobody except you, okay, that's the access session key anyway I'm talking about. So that it means that nobody except you. Okay, let me put this in red. Let me circle this in red. uh Let me circle this in red. So it means that nobody, okay, except you is to read the content message you sent or receive. Okay. So if you use the application session key, it's a security key anyway. So we're going to talk about a lot of it when we start dealing with when we talk about layers anyway. So here only you knows what you're the only one that can read of it, what you're sending and what you're receiving. No other person. Okay. So now the network session key, this very one, the one in blue, the network session key is used for interacting between the node and the network server. Okay. Now this key is used for the integrity of its message by its message integrity code. Okay. There's something called the MIC, that is message integrity code. All right. So it's a function you can use to check your message. Okay. So now the message integrity code that the MIC is similar to the checksum. Some of you that must have done some of you that have done web. Okay. You've heard something about the checksum. Okay. We're going to talk about that later on. So it's somehow similar to the checksum bit, except for the fact that it prevents international tampering. Okay, it prevents international tampering with a message. Okay, so for this, LoRa Wan uses there is a particular security there's a particular called the AES dash C C mark that C mark okay, don't mind my write up. Okay, I'll apologies for this write-up. I'm gonna get my pen very soon. Okay, so apologies for the write-up. So there's a security protocol. This is a security protocol. So LoRa Wan uses this particular protocol anyway. So in the back end of the things, okay, network. So this modulation is also used to map a non-unique device. Okay, if there is a device that is not really unique, that like what can I say? Can I say registration or not really? That is not that is unknown. Yes, let me use the word unknown. So it's used to validate the information that passed through a device that is unknown. So now this two session key, the network session key and the application session key are unique per device. Okay, they are unique per device. So per session, if you dynamically activate your device, okay, now using the OTAA, okay, just I talked about the OTAA previously. So if you put up your device using the OTAA, all right, now these keys are regenerated, okay, these keys are regenerated on every activation, okay. So now if you statically activate your device using the ABP, okay, now you have to hard code the device. You have to hard code the key in your program before uploading it. All right. You have to hard code you have to hard code it into it before uploading it. So change on just as far as that can go. So you have the devices that are being connected to this, and before everything is done, it has to pass through keys. So at every point you have these keys here, you have these keys, the keys are just everywhere to check what you are sending. So a lot of things I really I would like to send to you because of time. Very soon I'll be asked to be limited. So see, all right. Please, if you are okay with me, if you understand what we've done so far up to this point, just give me a thumbs up. If you have a question, just drop a question in the chat, and then I'm going to pick up a question. If you're okay with what we've done so far, you understand what we've done so far, I just need to know so that I won't be running so fast. Okay, I've seen a thumbs up. I've seen one person. I need like one other person to let me know we're okay to move to the next slide before I move to the next slide. Waiting for some other person to give me. So that means if you don't, that means not everybody got what I said. So you drop a question, like I said, on me. For me, the chat chat menu. So I'm gonna see that. Okay, I'm not seeing any chat right here. Okay, I'm not seeing any chat right here. So another up. Okay. So I think I'm good to. We are good to go. We are good to go. All right. So now let's talk about the main device now. The LL. LoRa Wan module. All right, it's a LoRa Wan module. So it so by the way, on license, so you can choose any frequency at your choice at any location. Every frequency, their frequency range to every location anyway. So this particular module runs on a sub megahertz radio transceiver, okay, which is ideal for long range wireless application. Okay, it is designed for long battery life, which would just 4.2 milliamp active receive current. So it's very the current is very small. So you're able to get a lot of stuff, and then it can transmit up to 22 decibel with highly effective integrated power amplifier. So it's very good. So now it supports LoRa Wan. Okay, it supports this particular device supports LoRa Wan and also supports frequency shift key. Okay, modulation. So that which is very good for that, and then the radio is suitable for system targeting compliance. So with radio regulations, including all these radio regulations I just mentioned. So the continuous frequency range from 150 megahertz to about 960 megahertz. So it depends. So this is the internal architecture of the internal block diagram of this particular device. So it has the DC to DC converter. It has a data buffer. It has the SPI. It's bidirectional. This SPI is bidirectional. So it can receive by SPI. It can also send SPI. So this is the module itself. Okay, this is the module itself, and then it has a protocol engine. Okay, which receive power from the LoRa modem or SL if you're using the frequency shift key. All right, and then from there it takes it has an oscillator which gives timing to it, and then now send it to your power, your antenna, anything you want to get this. This is always my advice to people. I always prefer this antenna, okay, this other antenna to this other antenna. All right, this is just some of strip antenna, okay. But I always prefer this very antenna on top here, okay, this very one here to this other antenna. So this other antenna we can just buy it to attach it and then the technology. So this one you can has long range. Okay, this antenna has long range. There are some of them. Where can this be seen? In wireless, you can see some of these antennas in wireless microphones. Okay, you can see some of them in wireless microphones. Those black, you can see them in NRF also. NRF also is the protocol. You can see them also. Some NRF carries this, and then some ESP also carries this. Then so you just need to check out for the one you have. So these are your right speed, and it has a microcontroller on board, and then for receiving and transmitting, the pin for receiving and transmitting, and then the user button for one user button, reset button, and then a USB TTL, an LED to check between, and a jump off. If you want to transmit, just set this jump off pin. Okay, if you want to transmit, if you want to receive. Okay, so let me not take much of the time. Let's look at the advantages of this particular stuff. This particular LoRa Wan. LoRa Wan is for has an ultra low power. It has an advantage of long range. Okay. It also promotes deep indoor penetration. Okay, when I talk about deep indoor penetration, like if you're inside a particular confinement, yeah, it also gives you that. And then for other ones, it's license free. It's a license free spectrum, so you can use at any frequency of your choice. And then it's very good for geolocation. It has a very high capacity. It has public and private deployment. It has an end-to-end security. It has this is called footer. It supports footer that same way updates over the air. It also doesn't involve roaming, very low cost. The program is very okay. the ecosystem is very okay, and that's just that. So the applications of LoRa Wan is just very great, and then I'm going to stop here. I'm just going to mention a very few. So these are just the few applications of LoRa Wan. Okay, there are a lot of, you have them in homes. Okay, when you have them in homes, you have them in industries, you have them in health, you have them in environment. So for homes, you can use them for smart meters, parking sensors, smart cities. There are a whole lot of stuff you can do. You can also use it for, you can also use it maybe for tracking and home. Industry, you can use supply chain, logistics, automation, agricultural sensors, like I said, the water sensors, the humidity sensors, the soil, you can use for a lot of stuff. You can you want to extract the product from the production to the store. It's very very good. A hospital can use for safety, security sales is good, and then street lights, remote control application. The it has a lot of things it can be used for. That's a lot and a lot of things. So so these are the references that I use, okay, for this particular presentation. So I'm going to drop this. I'm going to drop this on the channel, okay, the Slack channel, and then I'm going to drop lots of documents that that are for LoRa Wan. I'm going to drop them there. Most of the time I was able to go like in depth because I needed to talk about the frequency shift key. I needed to talk about the shift spectrum or spectrum. I needed to talk about the spreading factor. I needed to talk about how they are being calculated. There are a whole lot of things that we needed to do, but time didn't really is not on the side. So maybe just look at the community. Maybe we can schedule a class for this again. So at this point, I'm going to pause here, and then I'm going to ask for questions. If you have any question based on what you've done, is there something you don't really understand? Okay, you can just drop it at the chat for me. I'm looking at the chat right now. You can just drop it at the chat for me, and then I'm going to. We have just a few minutes to run that through. We have just a few minutes to run that through. So if you have any question, just drop it there for me, and then I'm going to answer the question. Or I think because of time, I think I'm going to okay, drop the question on the Slack time. This is almost 7 o'clock. So okay. Drop those questions there, and then if there is, you could just ask me, and then I'll be there to answer you, and then let you know, just put it through and everything. So thank you so much for being a part of our class today. Thank you to everyone for being a part of our class today, and I'm going to see you some other same time next week. And next week we're going to look at something which is different from what is in a curriculum. I'm going to show you some of the how to do some connections. That's what we're going to do next time. We're going to do some connections, and then we're going to see how it works. So thank you so much for your time today.